It's your buddy Aaron X1 here, and today we will be talking about the famous equation E equals mc squared. So I would always wonder about this when I was younger, that, oh, what's E equals mc squared? Dad, can you explain it to me? Mom? But they didn't really know either. It's kind of vague and hard to understand. So E equals mc squared. First, let's talk about the equation. E is energy. M is mass, or for this matter, extra mass. M is extra mass. And then M is just mass. I'm in business with something. M is the speed of light. So when Mr. Albert Einstein wrote this, he didn't actually write it like this. He wrote it as M is equals to E over c squared. What this means is mass is equals to energy over the speed of light squared. So basically, let's say that you have, let's say that you have, I don't know, a watch, right? So let's say, here's your watch. Let's say you have two watches. Exactly same, atom for atom. Two watches, exactly the same, atom for atom, right? But one watch is working, one watch is not working. So this watch just keeps moving, right? It's working, but yeah, it's working, right? So it keeps moving. This watch, since it's moving, it will have more mass. And I know that you're probably thinking, what? How? If they're the same, well, that's where Mr. Einstein's equation comes into play. So this one is moving. Yeah, so that one's moving, working, right? So if they're the same atom for atom, then how? Here's where Mr. Einstein's equation comes into play. And remember, he wrote it like this. So c squared, it's a constant. Speed of light squared is a constant. M, this could vary, this could vary. M depends on E. The way Mr. Einstein wrote it, M depends on E. So the energy, in this case, the energy is the energy potential, mostly kinetic energy. So let's write kinetic and potential is the energy. Kinetic, again, this is relating to this. It's not actually, but sorry. Right now, this equation, I'm just doing it in terms of this, so it's going to be different than other things, but energy of the hands of watch. Like if you had a race car which was moving and a race car which was still, race car which was moving is going to have more mass because of the energy of the wheels, right? Hands of the watch, I said it was. The watch. C squared is just speed of light. I don't think I need to write that down. And then M, in this case, is going to be the extra mass. So let's say m1 is a real mass, right? So then the mass of this is going to be m1, the mass of this is going to be m1 plus m, because of the extra mass. So the energy, you measure it, then you divide by the speed of light squared. Very close to zero, extremely close to zero, but it's not zero. But by a minuscule fraction, so small you won't even notice it. This will be, the mass of this will be greater than that. Again, it's very small, so it's not, I mean, you can measure it, but it's very difficult. It's very small. But that's how Mr. Einstein's equation works. And remember, it's m is equals to E over c squared. That's how he wrote it. So if you want to be right, it's that. Alright guys, thanks for watching. Remember to leave a like, don't forget to subscribe, and don't forget to comment down below what would you like to see next. Thanks.